I am Dr. W. Dhanode from Kamla Nehru Mahavidyalaya, Nagpur. Today we are discussing the 7 crystal system in case of solid state. On the basis of symmetry of unit cell, the various crystals are divided into 7 basic units, and these 7 basic units are known as the 7 crystal systems. In these 7 crystal systems, the angle, as we know in case of crystal, there are 3 non-coplanar axes, and these axes make the angle alpha, beta, gamma, and the intercept ABC, and the geometry of this crystal depend upon this angle alpha, beta, gamma and the intercept. And as we know, these 7 crystal systems, we can say that 14 Braivais lattices are there. So there are 14 ways of arranging the lattice point in the in three-dimensional order, and these are known as the Braivais lattices. Braivais is the name of scientist who explained and given this arrangement in three-dimensional order. And these 7 crystal systems are cubic, tetragonal, orthorhombic, rhombohedral, monoclinic, triclinic and hexagonal are the 7 crystal system in which the angle and the interspace or the spacings are different, alpha, beta, gamma and the A, B, C. So on the basis of that we are discussing 7 crystal systems and 14 Braivais lattices in today's part. So today's topic is the solid state, and this is the part number 4, and in this part number 4 we are discussing the crystal systems. 7 crystal systems are there, and 14 Braivais lattices, and number of particles in the cubic unit cell. So as we know, on the basis of the symmetry, what is the crystal systems? As we know, there are 14 crystal systems are there, and on the basis of symmetry of the unit cell, the various crystals can be divided into 7 basic types, and these are the also known as the 7 crystal systems. And these 7 crystal systems along with their characteristics are given in the table are there, and it has been shown that there are only 14 ways or different kind of space lattices are there. In other words, we can say that there are only 14 ways in which the similar point can be arranged in 3-dimensional order. These 14 lattices also are known as the Braivais lattices. So the classification is based on different combination of lattice spacing, that is ABC, and along with the crystallographic axis and the angle, triangle alpha, beta, gamma. Any crystalline solid can be described in terms of one of these 7 systems. So as we have seen also what is the space lattice, and space lattice we have seen it is the irregular 3-dimensional arrangement of the identical point in the space, and in crystal it is known as crystal lattice. So lattice is a space on which the particles are repeated periodically in different direction, 1 direction, 2 direction or 3-dimensional. So there are total 7 crystal systems are there, and the 7 crystal systems are cubic, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral and triclinic are the 7 crystal systems. So here, so it is given here that by mathematical analysis it is shown that only the 14 different kinds of space lattices are possible. In other words, we can say that only 14 ways in which similar point can be arranged in a 3-dimensional order, and these 14 lattices are known as the Braivais lattices. And these 14 Braivais lattices are divided into 7 crystal systems. So 14 Braivais lattices are divided into 7 crystal systems, and these are the Braivais lattices here. These are different types arrangement is called Braivais lattices. So what is Braivais lattices? 14 Braivais lattices are there, and these lattices are divided into 7 crystal systems, and the possible combination of lattice points in which they differ only in the spacing, lattice point spacing ABC, also known as intercept, along the 3 axes, and the angle made by the 3 non-coplanar axes alpha, beta, gamma between these axes. and give the 7 crystal system. We can also say that 7 crystal systems are associated with 14 Braivais lattices. These are also known as 14 unit cell. So the 7 crystal systems are the cubic, and we have seen that is the 7 crystal systems are cubic, tetragonal, orthorhombic, rhomboidal, monoclinic, triclinic and the hexagonal systems. And already we have seen cubic systems are 3 different types. There are 3 unit cells in case of cubic: simple, body centered and face centered. So here in the next slide it is shown the table. These are the 7 crystal systems shown here and known as the cubic, tetragonal, orthorhombic. So these are the 7 crystal systems. Here in this system is cubic, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral and triclinic. As we see here, the axial distance is a ABC, that is intercept spacing. Here is a ABC, A, B and C are equal, and angles here in case of cubic, alpha, beta, gamma equals to 90 degree. Example of cubic systems are sodium chloride, potassium chloride, diamond are the example of cubic system. Second is a tetragonal, where A equal to B, but this B is not equal to C. And here alpha, beta, gamma again are the 90 degree, and examples are SnO2 and white tin are the example. In case of orthorhombic, A is not equal to B, is not equal to C. All the ABC are 3 different, and alpha, beta, gamma the angles are the 90 degree. And example is rhombic sulfur and potassium nitrate. Another is monoclinic, A not equal to B, not equal to C. Alpha and gamma are 90, but beta is not 90. Examples are monoclinic sulfur, sodium sulfate, hydrated sodium sulfate. Hexagonal have A equal to B but not equal to C. Alpha, beta are 90, but gamma is a 120 angle. And example is graphite and the magnesium. In case of rhombohedral, A equal to B equal to C, all are equal. In case of angle, alpha, beta are same, but the gamma equal to gamma, but gamma is not equal to 90 degree. So here alpha, beta are same, but gamma is not equal to 90. And example is a calcite. Triclinic example, A equal to B equal to, all the ABC are different and angles are also different. Alpha, beta, gamma are not 90 degree. Example is copper sulfate and potassium dichromate. So these are the 7 crystal system in which in this table it is shown the distances, axial distances and the angle made by the 3 axes, non-coplanar axis, and examples are given in this slide. So in the next slide it is shown 7 crystal systems are there, and the 7 crystal systems different are there: cubic, tetragonal, orthorhombic, monoclinic, rhomboidal, triclinic and hexagonal. And as we have seen, there are 14 ways of arranging the lattice point in the space, and these 14 lattices, Braivais lattices, these 14 ways are known as the Braivais lattices, and 14 Braivais lattices are grouped into 7 crystal systems. So these are the 7 crystal systems. So first one is cubic. So here types of lattices. So cubic are 3 types: simple cubic, face centered, body centered. As we have seen, simple cubic systems are those in which particles are present at the corners of the cube only, and face centered cubic system are those systems in which the particles are present at the corner of the cube, as well as particle is also present at the center of the 6 faces of the cube. So face centered. And what is the body centered? As we have seen, body centered, this is the cubic system in which the particles are present at the corner, as well as particle is also present at the center of the body of the cube. So here is cubic systems are 3 types: simple, face centered, body centered. In case of tetragonal crystal system, there are 2 types. Tetragonals are only simple and body centered. We have seen they differ only in the alpha, beta, gamma angle and the intercept ABC. So these tetragonals are 2 types: simple, body centered. Orthorhombics are 4 types: simple, face centered, body centered and the end centered or base centered. So 4 types are there orthorhombic. In case of monoclinic, Two types are there, simple and end-centered. In case of rhombohedral, only one, simple. Triclinic, only one, simple. Hexagonal, only one, simple. So these are the different types. And the 7 crystal system, these are the 14 Braivais lattices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So 14 Braivais lattices are there. Different lattices have been shown here of the unit cell and that exist in a different crystal systems. So this is the table shows what are the types of crystal systems. So 14 lattices are there and they are in a 7 crystal systems. So these are 14 Braivais lattices are shown diagrammatically here as we have seen. Cubic crystal system, in this case 3 are there. Name of the Braivais lattices are unit cell, simple, body centered, face centered. So here is shown 3 types. Simple, particles are present at the corners, and here this is the body center. So particles are present at the corners as well as particle is present at the center of the body of the cube. Face centered, so particles are present at the corners and also present at the center of the 6 faces, 1, 2, 3, 4, 5 and the 6 above and below. So these are the 3 types. The particles cubic systems have 3 types of lattices. Unit cell structure is shown here. This is 1, 2, 3. So 3 types are here: simple, body centered and face centered. In case of orthorhombic, we have seen orthorhombic have 4 types: simple, body centered, face centered and base centered or end centered. So 4 types are given, shown here. Simple, particles are at the corners, shown here. This is the number 1 structure of the unit cell. And here body centered, one particle is present at the body of the cube. Here orthorhombic structure. This is the face centered, particle are present at the center of the faces. And this is the base center or end center. And we know end centered or base centered are those particles are present at the corners and also at the faces, opposite faces of the unit. So here is, this is the center of face, this is center of face, they present oppositely. So this is the end center or the base center. So orthorhombics are unit cell structures are shown and there are 3 types. Tetragonals are 2 types, simple and body centered. Tetragonals are only 2 types. This is the arrangement. See the arrangement. Alpha, beta, 3 axes are there. Anyone you can take, and this is the simple or primitive unit cell. So this is primitive unit cell in case of tetragonal. This is the structure tetragonal, which is body centered. In case of monoclinic, 2 are there, simple and base centered. So this is simple one and this is the base center because 2 particles are opposite to at the center of the faces are there. So these are the 2 types in case of monoclinic, simple or primitive and base centered. And number 5, rhombohedral is only 1 type. This is the arrangement of unit cell. Simple only is there, particles are present at the corners of the unit cell. Rhombohedral is only 1 type. Triclinic is also simple and primitive, and this is the arrangement. See, the angles are different and the intercept are different. This is the arrangement. In case of hexagonal, 7th, again it is simple and this is the hexagonal type. 6 corners occupied by the particles here also, and forming this type of arrangement. Angles are different and arrangement of intercept are also different. So there are total 7 crystal system and 14 Braivais lattices are shown. So all the 14 Braivais lattices are included in the 7 crystal system. So 14 Braivais lattices are divided into 7 crystal system, and the arrangement of possible combination of lattice point depending upon the spacing A, B, C and the axis, 3 axes of along the 3 axes, and the angle alpha, beta, gamma made by the 3 non-coplanar axes. So these are the 7 crystal systems and 14 Braivais lattices. So we can say that Bravais is the name of scientist, and he has in 1848 he pointed out that all the 4 types of unit cell cannot exist in every crystal systems. From the geometrical consideration, he pointed out that existence of 14 space lattices. These are commonly known as Braivais lattices. Name is given because Braivais was shown, therefore name is given Braivais lattices. And different types of unit cell exist in the different crystal systems. Also we have seen and given in the table. And there are only 14 ways of arranging the lattice point in the space, and these lattices are known as Braivais lattices. So these are the 7 crystal system and 14 Braivais lattices are there. So here shown these 3 and 4 7, and then 7 and 4 11, 11 and 3, these are the total 14 Braivais lattices are there and included in a 7 crystal system. And so these 14 Braivais lattices are divided into 7 crystal systems. So these are very important. All the arrangement in the unit cell depends upon the angle alpha, beta, gamma and the intercept. The spacing on around the axis is a ABC. These are important. We have seen how they differ in the angle and the spacing. So in today's part that we have seen different types of arrangement of the particle, and here in today's part we have discussed the different different 7 crystal systems. And as we have seen, what is the unit cell? Unit cell is a smallest building unit which repeat in the crystal, which is known as the unit cell. And there are 4 different unit cells are there: simple unit cell, body center, face center and base center. And there are total 7 crystal systems. The lattice points are arranged in the space and give different arrangement of the lattice point, and therefore there are total 7 crystal systems in which they differ in the angle and the spacing of the axis. And there are 14 ways of arranging the lattice point in the space, and these are known as the Braivais lattices. So 14 Braivais lattices are divided into 7 crystal systems, and 7 crystal systems are simple, that is a cubic system, tetragonal, hexagonal, monoclinic, triclinic, orthorhombic and rhomboidal are these 7 crystal systems are there. And we have seen what are the types of crystal systems. In case of cubic there are 3 types, in case of orthorhombic 4 types. of different types of the unit cell we have discussed in today's part. In the next part we will discuss per unit cell how many molecules of the sodium chlorides are present per unit cell, that we are going to discuss the calculation and some aspect about the closed package.